All right, so this lesson is lesson 3.2, solving inequalities using addition and subtraction. So yesterday when we started lesson 3.1, I said to you, remember that solving inequalities is exactly the same as solving equations. So we're just going to use the same things that we've always used. Talking about properties, the properties for an inequality are just like the properties for an equation. So we have the addition property of inequality. Don't let this throw you off. All this says is that whatever I add to one side, I can add to the other. Whatever I add to one side, I can add to the other. So it's just like the addition property of equality, but it's called the addition property of inequality. And then we also have a subtraction property of inequality. Don't let this throw you off. All it says is that whatever I do to one side, I can do to the other. So if I subtract C from one side, I can subtract C from the other. Okay? All right, so let's solve. My first example, negative 8 is greater than or equal to D minus 2. Just like with every equation or inequality, when we're solving, we want to isolate the variable. So I need to get D all by itself. I'm going to do that by adding 2 to both sides. I have negative 6 is greater than or equal to D. Now yesterday we talked about inequalities. We always want the variable to come first. So the first thing that I'm going to do is rewrite this. I'm going to rewrite. So I'm going to write this as D, flip my inequality, is less than or equal to negative 6. I need to check that. How do I check it? I just plug in my solution back into the equation, or the inequality. Negative 8 is greater than or equal to negative 6 minus 2. Choom, choom. Negative 8 is greater than or equal to negative 8. That checks good. Lastly, I need to graph. Okay, so my solution is negative 6, 0. All right, so open circle or a closed circle. Well, it's less than or equal to, so that's going to be a closed circle. And then remember, I shade in the direction that my inequality points when the variable comes first. So I'm going to shade everything to the left. There you go. My second example says solve t plus 3 greater than or equal to 8. Again, we're going to graph and check. This example, I'm going to subtract 3 from both sides. T is greater than or equal to 5. I'm going to do the check. I'm going to substitute my solution 5 in for my variable. 5 plus 3 is greater than or equal to 8. 8 is greater than or equal to 8. That is true. And then I'm going to graph. Okay. So my solution, T is greater than or equal to 5. Open circle or closed circle? Yeah, it's going to be a closed circle. Closed circle on the 5. And then again, I'm going to shade in the direction my inequality points. Shade to the right. Okay, last example. Your baseball team has a goal to collect at least 160 blankets. At least. We talked about this word yesterday. Team members brought 42 blankets on Monday and 65 blankets on Wednesday. How many blankets must the team donate on Friday? How many blankets must the team donate on Friday? That looks like our variable. B is the number of blankets donated on Friday. That's our variable. Okay? Let's go back to this word at least. When I see the word at least, that makes me think of at least 160. That means I need 160, so it's equal to 160, or anything more than that. Or anything more than that. Yesterday we talked about that word at least, and we said that at least is greater than or equal to. So we can write an inequality for that. So at least greater than or equal to 160. And let's see, on Monday they received 42 blankets. On Wednesday, they received 65 blankets. And then B, my variable, is the number of blankets donated on Friday. 42 plus 65 is 107, plus B is greater than or equal to 160. I'm going to subtract 107 from both sides. B is greater than or equal to 53. So the team must donate, use that word at least again, at least 53 blankets. Okay. And that is it. Your homework is lesson 3.2, and your homework problem numbers and page number found on My Big Campus.